Welcome to the notes on proving triangles congruent by angle, side angle, and angle, angle, side. Before we get into these notes, we've got to remind ourselves, if we had two parallel lines and we had this line going through it called a transversal, it created a bunch of special angle relationships, and a lot of those angles were congruent. Specifically, let's take a look at, if I said this angle here was congruent to this angle right here. Well, why would that be? Remember, that was alternate interior angles, right? And anytime we had alternate interior angles, we knew that those were congruent. So what you'll notice today now is if I extend this line here and I extend this line here, I'll have two triangles. And if they tell you that something is parallel, I promise that you'll be using our alternate interior angles are congruent. So with that being said, let's take a look at our first example. So there's a picture very similar. It says given angle B is congruent to angle D. So I want to mark that. Angle B right here is congruent to angle D. All right, and it says that AD is parallel to CB. So now parallel does not mean congruent. So I'm going to put these parallel symbols. Again, that does not mean congruent. It means that they are parallel. But if they tell us parallel, you know what we're thinking now. All right, that says prove those two triangles are congruent. So when we're doing proofs, remember the first thing we do, always start with the given. So I'm going to say angle B congruent to angle D. Reason given. So again, I'm going to remember we need three parts to prove our triangle is congruent. So there's an angle. So I'll put a little A there. Okay, next up it says we got to put that AD, segment AD, is parallel to segment CB. And again, I can keep that underneath number one. I can just kind of list them separately. Both of those are given. So now we just talked about being parallel. If that's parallel, what do we know we're going to have? These are our parallel sides here. All right. This side's parallel to this side. And we've got this transversal that goes through them. Well, then I know that this angle right here, I'm just going to put a little dot, is going to be congruent to this angle right here. We can't use the other two because we don't know. This angle's kind of cut off. So it's got to be those two angles. And we're going to say that they're congruent. How come? Well, we're going to say angle BCA is congruent to angle DAC. Why is that? We just told you alternate interior angles. And you can write congruent after you want or just leave it right there. So there's our second piece, all right? There's another angle. We've got two parts. We need one more, all right? So you can see our picture, we've got two angles. Well, in red, you can see that they share this side. So we can say that this side right here, it's in both triangles. There's that reflexive property so that we say, hey, segment AC is congruent to itself. It's in both triangles, so obviously it's the same piece. It's congruent to itself, like we said. So that is the reflexive property. I can put a little note there. Hey, I've got my third piece proven congruent. So now I can prove it. So let's look at the picture. We got to determine which congruence theorem we can use. So the last step is always what we're trying to prove. That's always the last step. So triangle ABD is congruent to triangle CDB. And how come? Well, here's our two angles. So we got an angle here. We got an angle here. And the side is not in between the angle. So that is angle, angle, side. The congruent side is not between the two congruent angles. Okay, let's take a look at one more. All right, the perpendicular. So we've got that extra step. So again, start with our givens. All right, segment BM is perpendicular to segment AC. All right, so I'm going to BM AC. So I'm going to put my little right angle symbol because that's what perpendicular means. And also, angle ABM is congruent to angle CBM. ABM, CBM, that's these angles right here. Those two angles are congruent. And what's our reason for both? Well, those are given. So they've only given us one congruent part, so I'm going to put a little A there. I've got one part. Well, now let's use that other given information. Since we know it's perpendicular, we've got to state which angles are right angles. So we're going to say that angle BMC and angle BMA are right angles. You got to state that. How come? Because that's the definition of perpendicular. And you'll get used to using that terminology, but if they tell you it's perpendicular, I promise you're going to use definition of perpendicular. And then since they're both right angles, we are then going to say that those same angles are congruent. BMC congruent to angle BMA. The reason, step 3, right angles are congruent. They both measure 90, so they got to be congruent. So there's our two angles. So it's not until this point I can say I've gotten those angles congruent. And then you can see right here, there's that shared side. Anytime they share a side, you know it's going to be the reflexive property. So segment BM is congruent to itself. It's in both triangles. That's the reflexive property. There's our third part that we've proven congruent. Another side. Now we can end with what we're trying to prove, always that last step. And we can't do it until we've proven 3 parts, which we have. Triangle ABM congruent to triangle CBM. And what's the reason? Well, here's our 2 angles. Angle, angle, and then in between it is the side. So that is angle, side, angle. So when you have 2 angles and a side, you know it's going to be congruent. You just have to determine, is it angle, side, angle, or angle, angle, side? And then a quick reminder, you must always have 3 congruent parts to prove those triangles congruent.